On June 13th, 2010, we ran a very high density wireless LAN experiment at Meru Networks. What I'm going to share with you now is the parameters of the setup. In the test, our goal was to create a very high density environment where we wanted to approach one wireless device per square foot. So we used a space of 500 square feet. Within that, we packed 500 Wi-Fi clients, which was a mix of 802.11g, A, and N. And in the 802.11n clients, we had a mix of 2.4 only clients and dual band 2.4 and 5 gigahertz capable clients. And we had 500 of these packed in an area of 500 square feet. In addition to this, we had 45 devices doing multicast video streaming, and we had 20 phones that were constantly doing phone calls. And of course, the total mix of these 500 clients was a mix of laptops, netbooks, iPads, iPhones, iTouches, BlackBerry, Nokia phones, Ascom phones, and a variety of other devices. And in addition to all of these sort of real applications, if you will, we also induced about 100 megabits of end-to-end chariot traffic. So when you think about this network, it is really an intense or an extreme high-density environment. Again, 500 square feet, 500 devices, 45 video streams, 20 simultaneous calls, 100 megabits of traffic. So this was the environment, in other words, the end user environment that we just talked about. In terms of the wireless LAN infrastructure that was created to support this application workload as well as the end user workload, we had 7 access points. These were 802.11n access points, which was a mix of Meru's AP300 and 320 and the 320i, which are dual radio 802.11n access points with external antennas and internal antennas, running our production system director release 4.0 with all standard capabilities and standard features enabled. As you might see from some of our companion videos, Meru is unique in its ability to do what we call a single channel architecture, wherein we are able to paint the entire floor or coverage area with a single channel by means of having all the access points coordinate with each other and present a virtualized wireless LAN to wireless devices. And what we do in high density environments is essentially leverage the single channel concept. So if you can paint the floor with one channel, you can increase capacity by essentially layering more and more channels. So what we did in this particular environment to support this high density was create 4 channels in the 5 gigahertz range, and these were 40 megahertz wide, and 3 channels in the 2.4 gigahertz range, and these were 20 megahertz wide. Right? So we had a total of 7 channels. We enabled virtual port, which is a core Meru architectural construct that allows every device to essentially get its own virtualized access point in the network and see a view wherein every device has sort of its access point that it carries with it wherever it goes in the network. This is how we are able to support wireless like wired user experience and is a core principle of our virtualized wireless LAN. There are some companions video that explain more of the technical detail. For the purpose of this video, all I want to tell you is at the top level, all our core features were enabled, channel layering was enabled, virtual port is enabled on all the channels. We also enabled a feature called band steering, wherein dual band devices were preferentially moved to the 5 gigahertz band, so that we were able to evenly distribute the load across the bands. And then we also enabled load balancing, wherein within the channels, as you recall, Meru is unique in its ability to do channel layering. So within the channel layers of a single band, we are able to dynamically load balance devices across all of these channels, so that essentially the goal is to get an even spread of devices between bands and within a band between all the channel layers. Since multicast was obviously a very key element of our test, and multicast video is becoming more and more important in enterprise networks, we enabled Meru's multicast group management capability, which essentially does optimizations in terms of figuring out how to direct multicast traffic to those devices that have subscribed to multicast groups. And finally, in terms of the security mechanisms, we enabled both WPA2 PSK as well as clear. 75% of the clients were in WPA2 PSK, 25% of the clients were in clear. So this was the wireless LAN setup. Okay, so now we've talked about the end user environment, the devices, and then we've talked about the wireless LAN setup. So the following were the use cases that we show in this video. The first one is all the clients are essentially accessing web pages at 45-second refresh time. So they're constantly refreshing and doing web access. And this is essentially to create background data traffic, right? So an ambient data traffic going on in the background while we run 45 clients that are subscribed to a 1 megabit multicast stream. So this is adding an incremental traffic over the air, multicast traffic that equates to 45 megabits per second. And then we layered on top of that 20 phones that were making G711 client-to-client calls. Right? And on top of all of this, we added artificial workload, which is essentially running a chariot application generating 100 megabits of traffic. Right? So the total summary is all devices accessing web pages at 45-second periodicities, 45 clients subscribing to 1 megabit per second multicast video stream, 20 phones doing 64 kilobit per second G711 codec-based phone calls, and an additional 100 megabits per second of end-to-end traffic. So this is what you're going to see in the network, and what we want to show is obviously the quality, the density, and also in terms of web access, the response time. At the end of all of this, one of the things that we were really interested in is to understand how quickly clients could come back into the network if, in fact, clients came in a burst. Right? So what we did was we simultaneously rebooted all the access points and then allowed clients to come back into the network. And as you will see in the following clip in the video, clients were able to come back very quickly and effectively reestablish the network within a couple of minutes. Thank you and enjoy.